Okay, we're going to cover the actual drip line itself. What is included in the drip line, how does it work, and how do you maintain it and make sure it continues to last. So what we're talking about is the drip line that we install in the ground. First of all, when it's installed, the emitters should always be on the top. Sometimes it'll go to its side, but it should never be upside down. If you dig down and find the drip line is buried upside down, that is a problem. Sometimes it'll be on its side. Ideally, we try to get it with the emitters facing up, and I'll explain why that is here in a second. So the little emitters are these bumps that you're going to see in the drip line. Typically, those are every 27 inches apart, depending on which drip line we specified for your field. So you'll see here we've got an emitter here and an emitter here. So I'm going to go over the different kinds of emitters first. So there's two different types of emitters. This is a clear drip line here, so you can see how it's extruded in there a little better. The two different kinds of drippers are pressure compensating and non-pressure compensating. And these are blown up versions of the two emitters, so you can see a little better how they differ from each other. The actual size is going to look more like this. The pressure compensated version, what it does is it has a silicone diaphragm that's built into it. So it's a 3-piece emitter. It has a cap, a top, and then there's a silicone diaphragm that goes inside of it. So if we were to cut one of these open, you'd be able to see this tiny silicone diaphragm that goes in there. And basically what happens is as the pressure increases, it puts pressure on this opening or the orifice and it closes it. So the higher the pressure, the smaller that opening gets. So it's putting out the same amount of water no matter what the pressure is in the system. Non-pressure compensated emitter, you can see it's a simpler design. The water is going to come in here, it's going to go down through there, return back, and it's going to drip out the emitter path right here. So this chart here beside me really shows how that works. So if you look at the dark or the green line here, this is our pressure compensated emitter. It's the DripNet PC.16. It's the one we use on most pressure compensated fields. So down the bottom here we have pressure. So you can see once we get to 6 pounds of pressure on this particular graph all the way to 25, and that number would keep going, our flow, what comes out of that emitter, stays the same no matter what our pressure is. If we look at the Aries drip line or the Typhoon Plus, either one, and I've got the 0.18 and the 0.1, you can see that the flow increases as the pressure increases. So that's a non-pressure compensated drip line. We'll use those in areas where we have fairly flat fields or we have a uniform slope in the field. So part of the engineering process is we look at all of those friction losses, elevation changes, all of the parameters that go into hydraulics, and we look at the uniformity and we choose which drip line we're going to use or drip emitter based on your field. So those are the two different types of emitters. We have the pressure compensated versus the non-pressure compensated. Another variation in drip line is the diameter. So there's multiple diameters. The smallest is what we call the 636 or the 5/8 drip line. So that's what I've got here in my hand is the 5/8. This particular drip line here I've got connected to a riser. This is the 7/8. There's also 1 inch and an eighth, an inch and 3/8. 98% of the systems we do are going to be they're either going to be 7/8 or 5/8. Those are the two common sizes that we use here at NutriDrip. These are the couplers, the repair coupler for splicing or doing repairs. So it's just a real simple nut. You slide this in here, pinch your finger right here on the end, and then twist the nut out and then tighten it. And when that's tightened and done properly, that will not separate. Those are the repair couplers. We have those for all sizes of drip line. Okay, one of the other components to a drip line is how do we get it to last? And so the flushing component to a drip system is probably the most important part of a proper irrigation design. So here I've got a sample design pulled up of a field we installed. This is actually a research field we did with Bex, and we've got a sub-main or our feed line on this end of the field, and we have a flush line on the far end of the field. And we'll go out in the field and get you some pictures of what that looks like. The purpose for the flush line, though, is to increase the velocity inside this drip line to 1 foot per second. So remember I mentioned earlier that the emitters are going to be on the top side of the drip line. The reason is because our filtration is going to take out particles that would potentially plug up the emitter. So our filtration is sized to remove particles that would plug up this emitter. That's what it's designed for. There are very fine solids that we are not going to filter out. And what's going to happen to those solids is they're going to settle out in that drip line over time. Especially if we're working with manure water or surface water. We'll have silt, sometimes some real fine sand will get through, and that's not a problem. So it's going to accumulate in the bottom of that drip line. In order to get that to move, we have to increase the velocity to 1 foot per second. It's a very important number. That 1 foot per second is the flushing velocity that's required by NRCS to properly clean a drip system. So when these flush valves get opened at the end of the field, that's what happens. Is it's hydraulically been designed that that velocity gets to 1 foot per second. It's a very important number. And so a couple other notes on that. How long do you need to flush? You need to flush for however long it takes for water to travel from this distance to this distance at 1 foot per second. So if you have a field that's 1,200 foot long, it's going to require 20 minutes or 1,200 seconds for that water to travel from here to get that material flushed out. We can print the flushing times on there. A lot of times we'll just have the measurement. Most systems, it's somewhere between 30 and 40 minutes per flush is what it is. Another note is each zone typically has 2 flush valves, and those need to be opened individually of each other. In other words, you need to open one flush valve, flush it for, say, 30 minutes, then close it, open the other flush valve up, and flush that half of the zone for 30 minutes. A lot of times you can flush multiple zones at a time, but only one half of each zone at a time. It depends on your pump capacity, how many of those you can flush at one time. So flushing, super important, especially if you have dirty water. A lot of times we say if you have clean well water and you irrigate less than 12 inches a year, you need to flush 1 time per year. If you pump out of surface water and you're irrigating somewhere between that 6 and 12 inches a year, you probably need to flush twice a year. If you're working with manure water or something that has a lot of fine solids in it, you may need to flush once a month. It's part of the maintenance of the system. Make sure those flushings are getting done adequately. The other way to know if you flushed long enough is if you get clean water. So basically when you open that up, you're going to get some really nasty looking water come out, and usually you want to flush until that water is clean and it looks like you've carried all the sediment out. Okay, one other thing to know on the design and how this relates to the drip line and how your system is going to operate is in each zone we're going to have this printout that shows what your flow and pressure is supposed to be, and then what that application rate is. So let's just go through this one for example. So here, this is a research field, so we've got 24 rows of drip line. We're supposed to flow 15 gallons a minute for this zone number 2. So zone number 2 right here, it's 15 gallons a minute. It's a half an acre. The pressure for that valve is supposed to be 12 pounds of pressure at the supply. When we run at 12 pounds of pressure and 15.5 gallons an acre, we're going to apply 6/100ths of an inch of water in a 1 hour period. So if we want to put out 6/10ths of an inch, we need to run for 10 hours. So if we run 10 hours, we're going to put out just over a ½ inch of water. This is on a 40-inch drip line spacing. So it's important to know that if you back this pressure down, it's going to put out less water out of all of those emitters. On a non-pressure compensated system, it will do that fairly uniform. If we did that on a pressure compensated system, it's going to start starving the system, and we'll show you some graphics with a little more detail on what that looks like on a pressure compensated system. But just know that this flow and this pressure are super important, that they're set properly out in the field at your pressure regulating valves, and that you're checking that when the system turns on, am I achieving this pressure and am I maintaining this flow? If that flow is too high, we maybe have a leak in that zone. If that flow is too low, we need to check if this pressure is set properly, or if it's been running that way for a while, maybe we need to dig up some emitters and see if we have some plugging going on. Okay, the other important maintenance thing for drip line is actually cleaning the emitters. So these emitters, depending on the water quality, can need to be cleaned. As a preventive maintenance, we recommend running a cleaner through the line every 24 inches of water you apply. But there's a lot of variables that can impact the frequency of that. I'll refer you to this drip irrigation maintenance and operation document that NetFM has put together. It's a great document that has a lot of resources on water quality. But what we're going to be monitoring is, are there minerals that are precipitating inside this emitter and starting to restrict it? This is something we need to monitor over time, because what will happen if we start building up things like iron and manganese inside this emitter, our flow for that zone or that set of zones that we're running is going to start dropping. So if you have a controller, those are alarms we're going to set up to monitor that, and we're going to graph it over time, like over a 1 year time period, Did you start at 500 gallon a minute? By the end of the season, you're at 400 gallon a minute. That's a 20% plugging. We know something's inside that emitter. We need to come out and get some samples dug up. We'll look at what's inside there, take a sample of your water, and then inject usually either acid, chlorine, hydrogen peroxide, or a combination of those products to clean those emitters out. So that's the mineral buildup that we're worried about. We're using some acid-based fertilizers now that can not only fertilize your field, but they also clean the emitters at the same time. So the type of fertilizer you use is also a very important consideration. Things like 1034O fertilizer, it will precipitate and plug these emitters. So some fertilizers can also cause problems. If we use an acid-based phosphoric acid, though, it's a beautiful source of fertilizer and phosphorus for the crop, and it also cleans the emitters. So some fertilizers leave behind a lot of waste in the system, some clean things out. So we have a lot of recommendations on the fertigation side that kind of integrate with keeping the drip line clean. We just want to make the point that this is very important to monitor this. Refer to this document, has a lot of great resources on how to clean it, how to do acid flushing in-house here at NutriDrip. We have a full department. Cortland Beyer leads that up and takes care of our water quality and helping growers. We actually come out and provide a service to acid flush and chemigate, or not do the chemigation, but to do the chlorine injection or hydrogen peroxide to keep these systems last a long time. We have a system in Nebraska that's been installed for 38 years and it's still running. So with proper maintenance and good water quality, these systems will last a long time. So it's really important we monitor that, and then we do the preventive maintenance to make sure that it keeps running. The other thing I want to mention is root intrusion. Root intrusion is a possibility on perennial crops. So things like alfalfa that have roots that grow 365 days a year. If they get thirsty, they go looking for water. So typically the problem shows up if you're in a deficit irrigation, meaning you don't have enough water to supply the plant's needs. Then those roots go looking for water, and they'll actually get inside that emitter and can plug up the emitter with roots. There are some chemicals we can inject to prevent that from happening. So most of the time, if growers have alfalfa on limited water, we're going to recommend that chemical to keep the roots burned away from the emitter, just to keep them away. There are other chemicals that we can inject to dissolve those roots if it does happen. There's treatments for all of these things, but always the ounce of prevention is definitely cheaper than the pound of cure. We want to get in front of those things, design a filtration system to take care of the minerals, put the preventive maintenance in place so that we don't end up with problems down the road. Super important part to understand how this works, what a drip line is, what the emitters are, and how they function.